We're going to start by talking about different ways to represent multiplication. So if I wanted to say 3 times 5, I could do it like the classic way, 3 times 5. I could do it with the dot, 3 times 5. I could use the little asterisk. We use that a lot of times if we're on a computer or something. And then my favorite, 3 times 5 with the parentheses. When there's no symbol, that means multiply. So now ways to represent division. If I wanted to say 10 divided by 5, I could do that with 10 divided by 5 or 10 divided by 5. Again, that is read as 10 divided by 5, not 5 divided by 10. Then I could do 10 slash 5, which is a way to do like a fraction essentially, and then 10 divided by 5, because remember the fraction bar means divide, which brings us to this next thing. The fraction bar means divide, so I can write a division expression with the fraction bar. So this would say 48 divided by 5, and this reads 48 divided by 5. And I could also write that again as 48 divided by 5. Now to turn a mixed number into an improper fraction, I'm going to multiply my denominator and whole number, keep your numerator, and add your original denominator. So I'm going to start by doing 3 times 7 is 21, plus 2 is 23, and I keep my denominator of 7. So those are equivalent. 3 and 2 sevenths is the same thing as 23 sevenths. They're just expressed in different ways. The next one, 9 and 1/5, I'm going to do 5 times 9 is 45, plus 1 would be 46, and my denominator stays 5. So 9 and 1/5 is equivalent to 46 fifths. To turn an improper fraction to a mixed number, you're going to divide and then go around the world is what I say. So if I have 36 fifths, top dog goes in the house, which means the top number goes inside. So 36 divided by 5, and then 5 goes into 36. That would be 7 times, which is 35. I subtract and I get 1, and I'm going to go around the world. So 7 and 1/5. So 36 fifths is equal to 7 and 1/5. This next one, 42 ninths, that's 42 divided by 9. 9 doesn't go into 4, it goes into 42 4 times, which is 36. I subtract, I get 6. Then I go around the world, and I'm going to get 4 and 6 ninths. But that 4 and 6 ninths can simplify to 4 and 2/3. So 4 and 2/3 is equivalent to 42 ninths. Okay, types of decimals. You have 2 types of decimals that we're going to talk about. That is the repeating decimal and your terminating decimal. A repeating decimal is just a decimal that has a digit or digits that repeat forever, and you just put a bar over the repeating part. Terminating is just simply a decimal that ends, so you'll get a remainder of 0. This first example, we have 0.3333 dot 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 dot. To represent that, I would say 0.3 and a line over it, because that's the repeating part. If I look at this next one, the thing that repeats is the 1/5. If you see that, it's 1/5, 1/5. So I would say 12.415, and the line will go over only the 1 and 5 because that's the repeating part. Now we're going to talk about fraction, decimal, percent. So first, percent is out of 100. So 1 whole equals 100%. Notice the percent sign is after the amount. So we're going to talk about how to turn a fraction into a decimal, into percent, and vice versa. So quick overview, fraction to decimal, divide, decimal to percent, you move the decimal 2 places, that direction. Percent to decimal, you're going to move the decimal 2 places that direction, which would be the left. And then from decimal to fraction, you're going to just read it and write it. Now, how to turn a fraction into a decimal? To turn a fraction to a decimal, one way you can do it is using equivalent fractions. This works only if my denominator can be multiplied to get to 10 or 100. So that would be, for example, those that have a denominator of 2, 5, 10, 20, 25, or 50. So I can either make it something where I make an equivalent decimal equal to 10 so that it's in the tens place, or 100 so it's in the hundredths place. So an example, I have 3/5. I could multiply that by 2 halves, which essentially is 1 whole. And that's going to get me 6/10, which is read as 6/10, which is 0.6. I can also, another example is 7/20. I can multiply 20 times 5 and 7 times 5. So essentially I'm still multiplying by 1 whole. And that's 35/100, which is 35/100. So 7/20 is equal to 35/100. But that does not always work, because that only works if you have those certain denominators. So what works every time? That would be division. It works every time. Now, here's a little tip. Try simplifying the fraction before you divide. That can make it a little bit easier. So when I'm doing this, I'm going to do the numerator divided by the denominator, which turns into that, because remember, top dog goes in the half. So 6/9, I'm going to use that little tip, and I'm going to simplify that first, which I could divide both of those by 3 and get 2/3. Now I can't make that equal to 100, so I'm going to have to divide. So I'm going to do 2 divided by 3. Again, the top dog goes in the house, meaning the top number. Then 3 does not go into 2, so I put my 0, and I'm going to put a decimal 0. I bring that decimal straight up. 3 goes into 26 times, which is 18. I subtract and I get 2. So I add another 0 and bring it down. That's 20. It goes in there 6 times, which is 18. I subtract, I get 2. Add another 0. Uh-oh, I see a pattern here. I keep getting this 20, 20, 20. So I'm going to keep repeating. So what I'm going to do is I'm going to say that 6/10 repeating. So I put the bar over it. This next one, 5/8. Again, I can't make that equal to 100, so I have to divide. So I'm going to do 5 divided by 8. So I'm going to start by trying to put, or 8 doesn't go into 5, so I put a 0. And then I'm going to add a decimal 0, and I bring that decimal straight up. 8 goes into 56 times, which is 48. I subtract and I get 2. I add a 0, bring it down. I don't stop. I can keep going. I'm not getting the same numbers. So 8 times 2 is 16. Subtract and I get 4. Keep going. I add another 0 and bring it down. 8 can go into 45 times, which is 40. I subtract and I get 0. So that is a terminating decimal because it ended with a remainder of 0. So 5/8 is equal to 625 thousandths. Now, to go from a decimal to a percent, I'm going from decimal to percent, so I'm going to the right to D to P. So I'm going to take the decimal and move it 2 places to the right. Essentially, you're multiplying by 100. So I have 7/10. I move the decimal 1, 2, so I have to add a 0 to hold its place. So 7/10 is equal to 70%. Those are equivalent. It's just expressed in a different way. This next one, 5/100, I'm going to take the decimal point and move it 2 places, which is going to make that 5%. This next one, a little bit trickier. You have 4/10 repeating. Okay, that 4/10 just keeps going on and on and on, right? So what that means is I'm going to take that decimal and move it 2 places, but then I have 44.44444444. So I'm going to say 44.4 repeating percent. The next one, I have 1 5/10. That is more than 1 whole, so you know that that's going to be more than 100% because 1 whole is 100%. So I take that decimal and I move it 2 places, which means I have to add a 0. And that means 1 5/10 is equal to 150%. Now this next one, I'm going to talk about turning a percent to a decimal. So FDP, I'm going from P to D, so that means I'm going left. So I move the decimal 2 places to the left, which is really dividing by 100. Now, a little tip. Remember that there's a decimal at the end of every whole number. It's invisible. If we don't see one, there is one. It's just invisible. So 53%, there is a invisible decimal right here. And I'm going to move it 2 places to the left. 1, 2. And that puts it right there. So 53% is equal to 5/300. The next one, 115%. I know that 1 whole is 100%, so I know that that is more than 1 whole. So there's that invisible decimal right here after the 5, and I move it 2 places, 1, 2, and it goes right there. So 115% is equal to 1 1500. 8%, invisible decimal right there, and I'm going to move it 2 places. So that makes it right there, and I put that 0. So 8% is equal to 8/100. Now, how to turn a decimal into a fraction. Simply read it, write it, and simplify it. Okay, real quick, place value. Remember, there's a trick you can use. If you put a decimal under, a 1 under the decimal point and a 0 under every digit, that helps you remember the place value. So that would mean if I put a 1 right here and a 0 there and a 0 there, that says 100. So that reminds me it's 48/100. And then I ask myself, can I simplify that? Yes, I can divide by 4. And I'm going to get 12/25. And when I say divide by 4, I really mean 4/4, which is really 1 whole, which anything divided by 1 is itself. So 48/100 is equivalent to 12/25. This next one, how do you read that? I'm going to read that as 3 45/100. Now I'm going to simplify that, and I could do that by dividing by 5/5. And I'm going to get 3 9/20. So 3 45/100 is equivalent to 3 9/20. Okay, now we're going to talk about some fraction, decimal, percent word problems. The first ones we're going to talk about, the first type of problems, is you can always make a fraction to turn into a decimal percent. And if it's a percent, percents can be turned into a fraction and simplified as well, because we know the denominator of a percent would be 100, because percent is out of 100. So let's do this first example. Mrs. Schuler bought coffee 15 days this month. If there were 24 days so far, write a decimal and a percent to represent how often she got coffee. Well, I know that I got coffee 15 out of 24 days. So there's my fraction, and I can turn that into a decimal and percent. So remember FDP, I'm going to first divide, and then I'll move the decimal 2 places. So first, remember I said what tip you could do is see if you could simplify the fraction first. And 15 and 24 are both divisible by 3. So I can divide by 3/3, and I'm going to get 5/8. Now I can turn that into a decimal by dividing 5 divided by 8. And I'm going to go through this quickly because we actually did this in example earlier. So this can go in there 6 times, which is 48. Subtract, I get 2, add a 0, bring it down. That's 16. Subtract, I get 4, add a 0, bring it down, which is 5, which is 40. So that's 625 thousandths. And then to turn that into a percent, I would move, again, I'm going to the right from decimal to percent. So I'm going to move the decimal 2 places, and I'll get 62 5/10%. All right, this next one. Students were asked to pick their favorite subject. Write a fraction to represent that the students, that's supposed to say the students, that chose reading or writing as their favorite subject. First of all, let's just notice that math was the biggest. Coincidence? I think not. So it asks for reading or writing. What that means is I want someone that picked either reading or writing. So what I'm going to do, I am going to add the reading and writing together. Okay, so when the question's asking for this or that, okay, what's the fraction that picked this or that? That means they could have either picked reading or writing. So what I'm going to do is remember that percent is out of 100. So if I added this all up, it's going to add to 100. So how many picked reading or writing? 14 out of 100. So to turn that into a fraction, well, that is a fraction. So I just need to simplify that. And I know I can divide the numerator and denominator by 2. So I divide 14 hundredths divided by 2 halves. And that's going to get me 7/50ths. So 7/50ths chose reading or writing as their favorite subject. This next example, 40 students were asked to pick their favorite season. Write a decimal and percent to represent the fraction that chose spring as their favorite season. A little typo there. So spring as their favorite season, we look and, well, first of all, it tells us that there were 40 students, but we could also add that up to get 40. And I'm talking about spring. So how many people chose spring? 8 out of 40. So remember, I can simplify this fraction first, which I can in this case. I could divide both by 8, and I get 1/5. So I can do this 2 ways. This one has that pretty denominator that can be multiplied to get to 10 or 100. If I do that, I can get 2/10, which is 2/10. But I can also divide 1 divided by 5. So I'd put the decimal 0, bring that decimal up, 5 goes into 10 2 times, which is 10, subtract, and I get 0. So I know that it's going to be 2/10. Now to turn that into a percentage, I move the decimal 2 places. So I'm going to get 20%. So 2/10 and 20% are my answers. This next one, what percent of the boxes are shaded? The first thing I'm going to do is find the fraction that's shaded. So I'm going to count. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 shaded. Out of, let's see, this is 5 and 3, so that's going to be 15. Can I simplify that? Let's make life easier. I can divide by 3, both on the numerator and denominator, and I'm going to get 4/5. I can do this by, this does multiply to get a denominator of 10, or I could do 4 divided by 5. Again, top dog goes in the house. I add that decimal 0 and bring the decimal straight up. 5 doesn't go into 4. It goes into 48 times, which is 40. I subtract and I get 0. That's 8/10, but it asks me for a percent. So I'm going to take that decimal and I'm going to move it 2 places to the right because FDP, I'm going from decimal to percent. That's going to the right, so that's what I'm going to do. So that's going to be 80%. Now let's do another question. Remember, if you're looking for the total of something, the total percentage should equal 100 because 100% equals 1 whole. So let's do an example. Ms. Schuler spent her day doing various things. If she spent 40% of the day teaching, 1/10 of the day grading papers, 1/4 of the day sleeping, 2/10 of the day adulting, and the rest of the day relaxing, what percent of the day did Mrs. Schuler spend relaxing? Well, I know it all has to add to 100%. So what makes that 100%? Well, I know that there's teaching, there's grading, my favorite, sleeping, adulting, aka taking care of the kids, cooking, cleaning, whatever, and then relaxing. So it says that teaching was 40% of the day. Grading is 1/10. So I need to turn that into a percentage. So FDP, if I'm going from decimal to percent, I'm going to move the decimal 2 places to the right. So that's going to be 10%. Sleeping was 1/4. So I can either make an equivalent fraction or I could do 1 divided by 4. Add that decimal and the 0. 4 goes into 10 2 times, which is 8. Subtract, get 2, add a 0, and 4 goes into 25 times, which is 20. So that's 25/100, which if I turn that into a percentage, that would be 25%. It'd be great if you already knew that because we know quarters, that 1/4 is 25%. Adulting, it says, was 2/10 of the day. So turn that into a percentage, 1, 2. So that's going to be 20%. So let's add up what we've got so far. I have 40% plus 10%, 25%, and 20%. So I'm going to add that up, and that's 5, and then 4, 5, 6, 7, 8, 9. 95% of the day is accounted for. So what is left? Well, I know it has to all add to 100. So that means 100 minus 95 is 5. So that means there's 5% of the day is relaxing.